Good evening, guys. Good evening, everyone. Good evening.
Good evening, teacher.
So there was that number which was saying
Only 9 people.
a continuous. I was waiting for people to come in. A continuous random variable X has a PDF of X given by f of X is equal to K 0 less or equal to X less or equal to 2. Add K of 2X minus 3. 2 less equal to X less or equal to 3. 0 elsewhere. And the first question was saying determine the value of K. Question 1 was saying determine what? Lisonga. Okay, she has muted finally. So the first question was find K, then sketch the graph. Of f of X. Then C was probability of X is less than 1. 2, probability of X is equal to 1. 3 of C was probability of X greater than 2.5. 4, it was a conditional probability of 0 less X less 2, given that X is greater than 1. Now to start with, the first definition, I can either use integration or I can use plotting. If I use plotting, the graph will look like this. If this is X, this would be f of X. When X is 0, it is a constant, K. Does not vary with X. When you look at this part, there is no X. So it's independent of X, so it remains K until you reach where? Until you reach 2. So if 2 is here, what happens? It starts, it has a positive gradient. So a positive gradient looks like this. So it's another straight line graph until you reach K is 3. I mean X is 3. When you reach X is 3, at that instant, you'll have 6 minus 3, and this will be 3K. Now, according to this, you can find the area under the graph. Remember, I told you the graphical method, you can use area under the what? Area under the graph. So area under the graph, this has area 1, area 2.
Teacher,
Yes,
excuse me,
please.
teacher. First pattern on the graph again.
Where exactly?
How we have begun to draw it.
In the beginning, this was f of x was k. There was no x. So between 0 and 2, it does not depend on what? On x. So the function f of x is a constant, which is here. That whichever value of x you have, the value of k is a constant from 0 up to 2. When it reaches 2, it reaches on this function of f of x, which function is in the form mx plus c. So it's a line with a gradient 2, which is positive. So you draw a positive line, a line with a positive gradient, which is this one, until it reaches 3. So 3 is up there. I mean, it is down here. But the value of f of x at that instant is, when you put in 3 here, you'll get a 6. 6 minus 3, you get 3k. That's why I have this 3k here. Is that okay?
Yes, teacher.
Now I can use this to find the area under the curve. And when I get the area under the curve, it has to be equal to 1. I'm also going to show you using integration, and we confirm whether I get the same answer. So area 1 plus area 2, they all should give me 1. So area 1 is 2 times k plus area 2, which is a trapezium, which will be a half. The height is 3. This is the height. This is A. This is B. So the height is 1 into k plus 3k is equal to 1, giving me 2k plus 2k is 1. Because this is 4. Divide by 2, you get 2k. Therefore, k is what? A quarter. That is how we get k using the method of area under the graph. But I told you it only occurs best if you have a graph which is in form of lines. If there is a curve somewhere, it becomes complicated. So it requires you to integrate at all costs. Okay? Now let me show you the other method of integration. Or the integral of all x of the function of f of x dx, it has to sum up to 1. So I will integrate from 0 to 2, integrating k with respect to x, plus the integral from 2 to 3 of k into 2x minus 3 dx. This should give me 1. This will give me k of x from 0 to 2 plus x squared minus 3x of k from 2 to 3 is equal to 1. When you substitute, you shall get 2k plus, yes, please.
I'm requesting you repeat the properties.
You are not here during the day. Eh? Your network is breaking.
I joined.
You joined late, eh?
Late.
Okay, I'm going to give other properties of mean and variance. When I'm giving them, I'll give also the others. Okay, so when you put x is 3, you'll get 9 minus 9. Minus, when x is 2, you'll get 4 minus 6 is equal to 1. This will give us a 0. This will give us negative 2, which is a positive, giving us 2k plus 2k, which is still equal to 1. Therefore, still k is equal to a quarter. The most important property we are using here, mister, is the integral of all x of the entire function of f of x. When you integrate it with respect to x, you must get 1. The reason why we are splitting them, it's because this one ranges from 0 up to 2. plus the integral of this f of x from 2 up to 3. The rest are zeros. So only these two without a zero are the ones we integrate. And when you integrate, you must sum them to 1 because it is depicting the total area under a graph. So I've done two things here. I've sketched the graph, and at the same time, I have found the value of k. But if you wanted to have it in terms of no k, then the graph would have been sketched like this. Yes, please.
For me, I don't understand how you set the graph by the integration. I understand.
You've not understood how what?
How you scale?
Your network is not coming.
I mean,
Hello?
teacher, I didn't understand how you scale.
You did not what?
But I haven't understood the graph.
The graph, eh?
But the I've understood.
You want the graph, eh?
Yes.
Eh? Okay, I'm repeating the graph, but this time using k is a quarter. Meaning, I'm using this one. It means f of x is equal to a quarter 0 less x less or equal to 2. Then a quarter into 2x minus 3, 2 less than or equal to x less than or equal to 3, 0 elsewhere. Let me use this to plot the graph. A quarter shows that this is f of x. It is independent of x. So initially f of x is a quarter. But this a quarter runs from 0 up to where x is 2. So it will run as a straight line up to x is 2. When it reaches 2, it becomes a line with a gradient 2. When you have a line with a gradient 2, it is a positive gradient. So it will have a shape of this kind. That's how a line of a positive gradient looks like. But this will stop at what? At x is 3. Okay? And at this instant, what will happen? The value of f of x will be, when you put there 3, the value of x will be, you'll get 6 minus 3, it will be 3 over 4. Which corresponds to 3k. I don't know that the person who was asking about the graph is now better. Okay? Now, probability of x less than 1. It implies you're integrating from 0 because the beginning value is 0 up to 1 of f of x dx. But the f of x between 0 and 1 is k, which is a quarter. So we shall get integral of a quarter dx from 0 to 1, giving us a quarter x from 0 to 1. And the answer is a quarter. Then there is another one. Probability of x is equal to 1. Probability of x is equal to 1 is 0. Why? It's because x is a continuous random variable. You know what that means? It means you cannot just have X alone. It has to be running from one point to another. That is what we mean by saying it has to be a continuous random what? Variable. So this is a continuous random variable, so you cannot have X is equal to 1. It is not continuous. From if it is 1, where is it starting from and where is it ending? It is just there. So it has to be continuous from one point to another. So if it's not continuous, then it is 0. If you're under continuous random variables, and then you get probability of finding one distinguished what? Point. This occurs in discrete. Then thirdly, we had probability of X is greater than 2.5. Now this is continuous because it is asking you to find the integral from 2.5 up to the last value, which is what? 3 of the function in terms of X, which is existing there. And that function existing along that line is the one for integral of 2.5 to 3 over quarter into 2x minus 3. That's where 2.5 and 3 lie. When you integrate, we shall have x squared minus 3x from 2.5 to 3, with this having a quarter outside. When you put 3, we get 0. A quarter of 9 minus 9, minus the lower limit, which is supposed to be what? 2.5 squared, you get 6.25, minus 3 times 2.5, you get 7.5. When you subtract the 2, you get 1. No, you get 1.25, a negative, which is a positive, so it will give us 1 over 4 times 1.25. Calculator, what answer is this? 0.3 0.3 what?
125.
125. Remember, these are probabilities. Answers must be ranging between 0 and 1. At any one point, when you get an answer beyond 1, or which is a negative, stop working and revisit the number.
Oh, I even got a negative.
You got a negative at some point. Those who tried out this number, I think you're seeing where you went wrong. Eh? Okay, the last one says probability of 0 less or equal to x less or equal to 2, given that x is less than or equal to 1. Yeah? Was it less than or greater than? No, it was greater than. Now, this is conditional probability. Yeah? Conditional probability reminds us that if you have probability of A given B, you must get the probability where A and B lie, that's the intersection, over probability of B. So it means this is going to be probability between X is greater than 1, yet this is 0 up to 2. So if X is greater than 1, it means it lies between 1 less or equal to X less or equal to 2 over probability of X greater than 1 or equal to 1. So this upper one can be identified straight away. The upper one is the integral.
Teacher,
Yes, please.
I haven't understood what you are writing there.
Yeah. Can I use the next page so that I don't rub off? The question says probability of 0 less than or equal to x less than or equal to 2, given x is greater than or equal to 1. Look at this. You're looking for the intersection, eh? 0, 1, up to 2, not so. This second one says from 1 and beyond. So the intersection is 1 and what? 1 and 2 is the intersection. So for conditional probability, if you have probability of A given B is equal to probability of A intersection B over probability of B. So what is the intersection of these two? The intersection of those two is ideally what? We have seen it is 1 and 2, which is equal to probability of 1 less than or equal to x less than or equal to 2 is our intersection divided by probability of x greater than or equal to 1. Now, according to our question, the integral from 1 to 2 the integral from 1 to 2 of f of x dx, you will divide it with integral from 1 up to 2 plus the integral from 2 up to 3. Because these two are different, whereby the upper one will be integral over a quarter of dx of 1 to 2 divided by integral of 1 to 2 over a quarter dx plus integral of 2 to 3 over a quarter of 2x minus 3 dx. And when you substitute, you'll get a quarter x from 1 to 2 divided by a quarter x from 1 to 2 plus a quarter of x squared minus 3x from 2 to 3. This will give me a half minus a quarter divided by a quarter plus, we saw that when you put 3 you get 0. Then when you put 2 you get a half. It will be 4 minus 6. Yeah, you get a half. So the answer would become a quarter over 3 over 4. Finally, the answer is a third. So the rest is algebra here. So ideally, the probability of 0 less x less 2, given x is greater than 1, the answer is a third. Hajari. Ni mu class. Okay, so that is how you have to go about that conditional probability. Damari Mandu, you have a question. Damari Mandu. There is also this other tricky number which confused the people. People are in my box.
Teacher,
Yes, please.
teacher, in this
Yes,
other, in this Roman number 3, this number that you are doing currently, I don't see any 3, but I'm seeing there you wrote, is it the integration of 3, then 2 down? Where did the 3 come from?
Hey, now the denominator was saying x greater or equal to 1. Now, when you go back to our question, it was ranging from 0 to 2, then 2 to 3. So it begins from here where 1 lies until it goes as far as where you stop here. That's why the 3 comes in.
Okay, thank you, teacher.
Welcome. Another person also had a concern. Someone else was asking. Here is this number. The first question was saying sketch f of x without finding alpha. Hmm? Now here you had to think. This is f of x. This time now it wasn't starting from 0. Look at the starting value. The starting value was a 2. If it was a 2, at that instant, f of x was alpha. So it begins from here. There is no x, then it remains a straight line until it reaches what? 3. Then after 3, it becomes a line with a gradient of positive 1. Until it reaches what? 4. Hence, this is where alpha is. This is where we have alpha into x minus 2. Then up here, we shall have what? When you substitute x is 4, you will get 2 alpha. So that's the shape of the graph. Then they said, hence find alpha. I told you here you can use area under the graph. When they say hence, pardon?
Please.
Pardon?
The way you drew the graph.
Yeah. I never began from 0, because the starting value is not 0. But I have to indicate the starting point. I mean the origin of the graph, which is 0, 0. So it begins from 2. When it begins from 2, it moves as a constant line because it is independent of x until when x is 3. Then after, it becomes a line with a gradient positive 1. A line with a positive gradient looks in that shape. A line with a negative gradient is in this shape. Now, if you land on a curve which will have a negative gradient, it will go down. That is if the x will have a negative on it. Or if it's an x squared with a negative, it will also go down. So with this, when they say hence, you use the area under the graph, which will be area 1 plus area 2, which will be 1 times alpha plus a half times 1 times 2 alpha plus alpha is equal to 1. Alpha plus 3 over 2 alpha is equal to 1. This will give me 5 alpha over 2 is 1. Our alpha will be 2 over 5. How many of you got that? Whether by integration or by area under the graph. Are there some people who tried it out? The reason why I give them to you is to come when at least you've done something.
Teacher.
Yes, please.
Teacher, first explain it once more.
How I've got the area?
Yes, teacher.
The length here is 1. Do you agree? The width here is alpha. Alpha times 1, you get alpha. This is a trapezium. Okay? This is the height h, which is 1. This is b in the formula for trapezium, which is what? 2 alpha. This is a in the formula for trapezium, which is alpha. Area of the trapezium is a half h into a plus b. Are you better now?
Yes, teacher.
Okay, hope you've these examples have stabilized your understanding. That is from the day up to where we are now. Because I want to bring in a new definition.
How did you get to alpha?
How did I get to alpha? I substituted x is 4. Where? Here. You would get alpha into x, which is 4 minus 2, giving you 2 alpha. Okay.
Okay, thank you.
How to get the expectation and the variance. The mean,
Teacher, how about the third number?
the rest try them out now. Which one?
Teacher, no, that one was extra hard.
First try
It
it out.
was extra hard. I couldn't even have any idea.
I'm sick like, did you pass the other one?
Teacher, I've tried it.
Did you pass the first one?
I passed one, I failed.
Hey,
Yes, teacher, I passed.
keep thinking. Which one was it?
This other one of departure time of students. The one whereby they drew the graph, then they expected us to find everything.
Okay, let me do an example on the graph, then you find everything. Let me give you an example and you do that number.
Okay.
Now, assuming
Thank you.
that is how to obtain f of x from a graph. For example, they can give you a graph of this kind. Then from 0 this is 1, this is 2, this is 3, and this is k. And they ask you to find the value of k. They can ask you for the value of k. Then they can ask you to express f of x algebraically, meaning they're asking you to design the function, the PDF. So to get k, you just get the total area under the graph, which is area is supposed to be 1, which is a half h times b plus 1. So the base is what? The base is 3. The height is k, should be 1. Therefore, k is equal to 2 over 3. Straight away, you can get k from the graph. Now, the second part is the interesting one. You see that the graph changes after between 0 and 1. So therefore, between 0 less than or equal to x less than or equal to 1, yeah? What is f of x? F of x is a straight line graph. How is it a straight line graph? It's a straight line graph in a way that it is f of x depending on k times x. It's a straight line. When you have a line y is equal to ax, that line looks like this, passes through the origin. So ideally, this is kx. Okay? So if it is kx, you would have, when you substitute k, you'll get f of x is equal to, when you put 0, you get 0. I mean, when you put k, you'll get 2 over 3 x. Okay? So after attaining that, you can now investigate between 1 less than x less than 3. Hmm? According to this one, we have a function. We have points, for example. Or you can use the method of gradients. We have a point here, which is 1, k. Then we have a point here, which is what? It is 0. So if you have a point which is 3, 0, so you have a point 1 and 2 over 3. And you have another point which is 3 what? 0. So find the gradient of that line so that you get the equation of the line. The gradient will be 2 over 3 minus 0 over 1 minus 3. And the gradient is 2 over 3 over negative 2, giving us negative a third. So if the gradient is negative a third, pick any point. You know how to do this from primary. Y minus 0 over x minus 3 is equal to negative a third. This will give me 3y is equal to 3 minus x. Y, when you make it the subject, becomes 3 minus x over 3, which ideally is 1 minus x over 3. But remember, y is a function in terms of x. So therefore, the expression of f of x would become, the first part was what? The first part was 2 over 3 of x, that is between 0 less than or equal to x less than or equal to 1. Then 1 minus x over 3 is between 1 less than or equal to x less than or equal to 3. Then it is 0 elsewhere. So that's how we can deduce such an equation or function from the graph. Now, according to that number, you also had the same. You can even use a graph throughout. For example, here in the first case, if I had used this point and 0, 0, you would see that if I had used for this one, or if I had used 1 and 2 over 3 and a point 0, 0, and I got the gradient M1 would be 2 over 3 minus 1 over 1 minus 0 over 1 minus 0, which is 2 over 3. So y minus 0 over x minus 0 is 2 over 3. And this is how I would deduce y is equal to 2 over 3x, which is the same as this one. What is it? Which is the same as this one. So you can use the idea of gradients. So lady who was asking, I think now you can handle your number.
Excuse me, teacher.
Yes, teacher.
Teacher, for me, I don't know what you even do.
I'm using knowledge of primary. We are looking for the equation of the line. You look for the equation of the line here. Look for the equation of the line here. By doing what? By getting the gradients. You get a gradient M1, get a gradient M what? This gradient, pick any point. The best point to pick is one which has a 0. Then for the second one, the best point to pick is this one. Then the functions you get in terms of y are the functions for the equation. This is primary work. It's just that we are applying it in advanced math. We did it in primary, senior 1, senior 2, senior 3, senior 4. My friend.
Teacher.
Yes, please.
So now you first begin to explain it from where you started, like y is equal to x there, up there.
Here I was using the shape of the line, but I think the line there was mixing you. So I've decided to bring you the option of using what? I've decided to bring you the option of using the gradient of the line, whereby in the gradient of the line, you can find the gradient of the first line. You assume this line was like this. You assume this line was like that, just a line. With a point here, 1, 2/3. Then here it is 0, 0. Then I ask you to find the gradient M1. M1 would be what? 2/3 minus 0 over 1 minus 0, not so. Giving you 2/3. Then get me the equation of the line. Y minus 0 over x minus 0 is the same as the gradient. So you'd get y is 2/3x. This is function f of x. Then go for the second particle. Second line. This was 3, 0. The second line, it has gradient m2, which is 2/3 minus 0, then 1 over 1 minus 3, which is 2/3 over negative 2. This gives you negative what? 1/3. Then y minus 0 over x minus 3 is going to give you negative 1/3. When you cross multiply, you'd get 3y. Okay, you'd get y is equal to negative 1/3 into x minus 3, which is the same as 1 minus x over 3. This is f of x, where between x is 1 and x is 3. So you come and rewrite them like that, and elsewhere you have 0. Are you okay, Mr. Now?
Excuse me, teacher.
Yes, please.
I beg your pardon on when to use the signs less than or equal to and less than.
Okay. Now, when they ideally, when these questions are set, for example, 0 less than or equal to 2, because it is continuous, yeah, it will continue from 1 up to 2. That's why we introduced the equal sign. But it is the same case. You have to integrate from that value up to where the other value is. Whether it's less than, whether there is an equal sign or there is no equal sign, because of the continuity definition. Because the random variable is a continuous one, we are integrating from that point to the other point. So whether it has equal to or less than, you have to include those points. They are the boundaries at whatever cost. Okay. I wanted to introduce this definition before we leave. The property of variance and expectation. So expectation or mean
So,
yes, please.
can't you begin the topic like tomorrow?
It's very easy, guys. And we might not meet next week. You're going back to school.
Oh,
You get my point, eh?
yes.
I wanted you to go and at least have a clue of these items. It's not so complicated. So the expectation is defined by this. The expectation or the mean mu is equal to the integral of all x when you multiply x times the function you have with respect to x. Then secondly, for variance, which is E, variance is got from E of x squared minus the expectation of x, but this is the mean squared. So one can write it as E of x squared minus mu squared. And in this situation, E of x squared is ideally the integral of all x when you multiply x squared by the function f of x dx. So I'm going to give only one example on this, and the rest you try them out. Then my friend who was asking me about the definition of the properties, also we had seen earlier that all x, if you integrate f of x with respect to x, you must get 1, which is area under the curve. Okay. Now, example. A continuous random variable x has a probability density function f of x, where f of x is equal to x over 8, 0 less or equal to x less or equal to 4, and 0 elsewhere. Determine 1. Expectation of x. 2. Variance of x. 3. Standard deviation of x. Like I've said in the definitions, E of x is the integral of all x by multiplying x times f of what? X dx. And you know what our x is going to be? We are going to integrate from 0 to 4, multiply x by x over what? 8, and then integrate. Our function is x over 8. So you multiply that function by x in order to get the mean. So this will give me integral from 0 to 4 of x squared over 8 with respect to x. When I integrate this, I'll get x to the cube over 24 from 0 to 4. How have I got the 24? The new power, which becomes cubed, is taken down to meet the 8. So 3 times 8 is 24. When you substitute 0, you get 0. When you substitute 4, you get 4 cubed is 64. So 64 divided by 24 by 8, 3 by 8, 8. So the answer will be 2.6667. Or you can leave it like this as the best answer. That is expectation. As long as you know the first items we have done. Here, expectation, you just add on 1x before you integrate. Then for variance, we need to first get expectation of x squared, which also is got by multiplying x squared by the function you have, then integrate all the x. So it will give me the integral from 0 to 4 of x squared times x over 8 dx. So you're going to see how cheap this is as long as you understood the earlier ones. Integral from 0 to 4 of x cubed over 8 dx. And this will give me x power 4 over 32 from 0 up to 4. This will give me 256 divided by 32. By 8 here, by 8, 4. By 8 here, it goes there, what? 32. By 2 here once. By 2 here, it goes there how many times? 8. Calculator, is that the answer? Yeah, that's the answer. So, to get the variance, it's got from expectation of x squared minus the mean squared, which will give us 8 minus 8 over 3 squared, which will give us 72 minus 64 over 9, which will give us what? 8 over 9. Then standard deviation is the root of what? Of variance of x, which is going to be the square root of 8/9. And then you get the answer. So as long as you've already understood how we have integrated earlier, when it comes to expectation of x, which is the mean, and expectation of x squared, which guides us on finding the variance, one can easily proceed and get the solution rightly. Unless someone has a question. Anyone with a question before I can send you numbers to try out? Muje tugende. The other parts like median, mode, you'll find them at school. But at least you go with the mean and the variance.
Teacher,
Yes, please.
the last part is the standard deviation.
It's okay.
Standard deviation is the square root. It is represented by a symbol sigma. It is the square root of variance of x. That's why you always see variance of x is equal to sigma squared. Yeah. I'm going to also send you some example write-ups so that you can go through. In case of any challenge, you get back to me.
Teacher,
Yes, please.
will I find those works in your Google class there?
I'm going to upload them then.
Okay, maybe you upload them there so that I can also get them there because I'm not there on.
Oh, because you're not on WhatsApp. Okay.
Thank you, teacher.
Any other concern, guys? Teacher, what of
Teacher.
mean and median? Median, I never wanted to proceed. People, it sounded tired. Oh, I show you median. Should I show you median?
Yes, teacher. No.
Okay, let me comment on median lastly, guys.
Yes.
Yes, someone was asking. The median looks at dividing the curve into two parts. Therefore, if it's two parts, each part will contribute 0.5 of the probability. So it means that if you integrate from negative infinity to where the median is, and you integrate f of x with respect to x, the answer you must get is 0.5. Or if you integrate from the median itself up to positive infinity, where the values end. Positive infinity means up to the end. Negative infinity means where you're beginning from. Of f of x dx, you'll also still get 0.5. So if it's a curve like this, and this way it's ending at positive infinity, and this way it's ending at negative infinity, then the median should be the value between here, whereby you integrate from negative infinity up to here, you get 0.5. When you integrate from the median up to positive infinity, the last value, still you get 0.5. When you add the two halves, you get 1. Okay. Now, with that sense, if the number is set, for example, you have a continuous random variable of this sort, x over 8, 0 less or equal to x less or equal to 4, 0 otherwise, and they ask you to find the median. Negative infinity in this case is 0. So it means I'll integrate from the smallest value, which is 0, up to where the median is, which is f of x dx should give me 0.5. Just like you had knowledge of total area under the graph. So total area for the median is 0.5. So I would get the integral from 0 up to m of x over 8 with respect to x should give me a half. And this will give me x squared over 16 from 0 to m is a half. When I put 0, I get 0. When I put m, I'll get m squared over 16 is going to be equal to a half. My m squared will be equal to 8. So my m will be equal to plus or minus 2 root 2. Now, when you get two values, you have to decide which value is the correct one. Because this question was ranging between 0 and 4, you are having m is positive. When you get a decimal, what answer do you get? 2 point what? Root of 8 is 2 point. What? Okay, let's stick to 2 root 2. Then also you have m is negative 2 root 2. Now this one is impossible because the value is positive between 0 and 4. So we choose this one. Now one may ask themselves, what if the question is not direct like that one and it has two ranges? And it has two ranges, like which one? Like f of x is equal to 0.4x plus 0.8. Negative 1 less or equal to x less or equal to 0. How I chose, you can see it. How I chose, I chose it a positive because x was ranging from 0 up to 4. And the x value, which is a negative, is outside 0 to 4. It is not a positive. So we choose the positive value. Is that okay? The person who asked, is that okay?
Yes, right.
0.8 minus 0.8x between 0 less or equal to x less or equal to 1. Then 0 elsewhere. I'm finalizing. This is the last example. So they say obtain the median. Now this one, pay attention very well. If you integrate and you get an answer which is beyond 0.5, you first check and see. You first integrate the first interval and see if it is at least, 0.5. If it's less than 0.5, it means the median is in the next interval. So you investigate and check. We can investigate by integrating from -1 to 0 and integrate the first interval, which is 0.4x plus 0.8 dx. This will give us 0.2x squared plus 0.8x from -1 to 0. When you put in 0, you get 0. When you put -1, you get 0.2 minus 0.8. But this one is going to be subtracted off because it is coming from 0 minus. So this will give you a positive 0.6. Now, if it is beyond or equal to 0.5, like I've said, it means the median lies in the first what? Interval. But if the answer I got here was less than 0.5, I would proceed and go to the second interval. I'll share with you some examples of that on the Google Class and WhatsApp, and you take a look at them. So I can now go back and say the median will be from -1 up to m. of 0.4x plus 0.8 with respect to x, and this median should be 0.5. Therefore, you would get 0.2x squared plus 0.8x from -1 to m is 0.5. When I substitute, what will I get? I will have 0.2 m squared plus 0.8 m minus 0.2 minus 0.8 is equal to 0.5. I've substituted -1. I'll get -0.6, which gives me a positive. So 0.2 m squared plus 0.8 m is equal to, if this is a positive, crosses over, it becomes a negative. So it becomes minus or plus 0.1 is equal to 0. Can you put this in a calculator and get the answer? But in a paper, you have to show the working. So this is the same as 2m squared plus 8m plus 1 is 0. Put this in a calc. Someone press the calc and give us the answer.
Negative 0.1.
Negative
129.
0.129 and
Negative 3.870.
I'm going home.
now to choose again which answer is the correct one. Which answer do you think is the correct one?
M1.
Yeah? Which one would be the correct answer? Because we are in the first interval, eh? Between -1 and 0. So which one would be the correct answer?
M1.
M1. So M2 is wrong. So M1 is the correct one because it lies within the range. Okay. Okay, with that, we can stop here. I also have to drive before curfew gets me. Unless if someone has a special burning question. Otherwise, we can stop here for the night.
Peter,
Yes, please.
Peter, you are still talking of when the probability is, when it is like more than 0.5.
Okay, if you had investigated and this one was 0.4, it means the 0.5 would be here. So you would come and say integral from -1 to 0 of the first thingy plus 0.8 dx. Then you add on from 0 up to the median of 0.8 minus 0.8x dx. It should sum up to 0.5. So you would add it on indirectly by not investigating this one. As long as if you investigate this first one, and the answer you get is less than 0.5. If it is equal to 0.5, it is okay. But if it is less, then you have to go to the next interval. So you add on the value you get for the first interval, which is 0.4, plus the integral from the extreme value, minimum value in the second interval, up to where the median lies of f of x dx is equal to 0.5. Then with that, you would get where the median is. I know with the examples I'm going to send, you'll land on those numbers. Please give them a shot. Huh? Any other sensitive concern? Yeah, okay. The last one I can comment on is mode. Mode, you just differentiate. The mode, let me just write it here. Mode is the value of X for which the Y, the X is 0. So if you differentiate your function with respect to X and equate it to 0, the X value you get is the mode. For example, here, when I differentiate with respect to X and I differentiate X over 8, the answer is 1 over 8. So the mode is 1 over what? 8 answer. Okay. The rest you'll discuss at school, don't worry. At least you have a glance of whatever will happen. So you can go with that. Keep me posted with numbers that you find challenging so that I can be of help. I'm not feeling so well, so if I take so long, tomorrow I'm going to hospital. See how I get out very fast. But if I take so long to answer your questions, just know I'll answer them at some one point. I'll just have delayed. Pardon?
Quick recovery.
Okay,
We are
thank
praying
you.
for you.
Thank you so much.
Teacher,
Yes, please.
you upload for me the work in your Google class so that I can access
Yes,
it.
please. I'm going to upload it. I promise.
Okay.
If I forget, guys, remind me to upload for that gentleman work.
Good night, teacher.
Good night.
Kako mio.